TCP versus UDP, these are the foundational protocols of networking and also internet communication. And it's important to know the difference between these two protocols and what they're used in and how you could take advantage of doing things with TCP or doing things with UDP if you're going to build something yourself on a low level, for example, using Rust. First up, in terms of real world examples, we have web browsers. That would be a TCP based application. So Chrome, Firefox, Safari, they use HTTP and HTTPS traffic. Email clients, for example, Outlook, Gmail, file transfer protocols like FileZilla, WinSCP for databases, MySQL Workbench for database clients, also remote desktop, RDP client for messaging platforms like Slack or Discord. So these are all things that many people are aware of. Now let's talk about UDP-based applications. Really, gaming is one of the strongest cases for UDP, and we'll get into why in a second. But online games like Fortnite, Call of Duty, video conferencing, so Zoom, Google Meet, these audio video streams are UDP-based. Streaming services, Netflix, YouTube, voice over IP applications, DNS resolvers, IoT devices. So why would we have these core differences here? One of them is that TCP is connection oriented. So this is a handshake that's required. UDP is connectionless. So it's fire and forget. So you're just sending data packets and you don't care if they're received. So the differences are that in terms of data delivery guarantee, TCP will require the delivery with acknowledgement and retransmission. UDP is best effort with no guarantees. With TCP, you're able to have sequence order of packets. With UDP, there's no guarantee. It just sends the data, and when it comes, it comes. In terms of header size, TCP is 20 to 60 bytes, so it's got larger overhead. UDP is 8 bytes, so minimal overhead. In terms of technical implementation, with TCP, we have this three-way handshake, SYN SYN-ACK ACK, with flow control via a sliding window, and they have congestion control algorithms as well built into it. And there's a positive acknowledgement with retransmission, and there's segment sequencing and reordering, and then full duplex operation. UDP, very different architecture, stateless packet delivery, no connection establishment, no termination phase, no congestion or flow control, checksum for basic integrity verification, and then fixed header structure. So the performance characteristics here are that with TCP, the latency is going to be higher due to the handshakes and acknowledgement. The throughput, you can achieve high throughput over stable connections, but there is this overhead. There's a 20% overhead you're going to get for the control traffic and also scalability. So you're going to get connection state limits with concurrent connections. UDP has much lower minimal protocol overhead, so it's a more lightweight protocol. The throughput is very high potential, but there's some problems with network congestion potentially. Also, the overhead is 4%, so very, very minimal compared to that 20% for TCP. The scalability is really good for broadcast or multicast. So the use cases here for TCP, again, would be web browser, email, file transfer, remote terminal like SSH, database access, or any application that requires complete ordered data. For UDP, this is live streaming, video conferencing, online gaming, VoIP communications, DNS lookups, IoT telemetry, time-sensitive applications. And then in terms of protocol extensions, we have TCP variants as well. Things like Google has a TCP alternative. We have UDP enhancements as well, adding TLS like security. Also, different protocols are being essentially enhanced, like UDP Lite, maybe a partial checksum. So the big takeaway here is that there's still even evolving protocols, but when would you choose one over the other? So for TCP, it's about data integrity. If that's critical, you should use TCP. If you require complete data transfer, so like a file, if you need to make sure that the entire file is there, you would want to use TCP. Network conditions are unpredictable or high loss, and also applications can tolerate some latency. When would you want to use UDP? This is real time, so partial data loss is acceptable. So again, like a voice or a video conference, right? Partial data loss is okay. Low latency is critical. Also, application handles its own reliability as well. So you might have to build your own layer on top for reliability. Even though you get that 4%, maybe you have to add another 5% to do some kind of reliability metric. So it's important to know about these two different protocols. You can implement them at a low level with Rust, and it's an interesting way to really get into the weeds. And also, it's important to understand this from a debugging perspective: when to use TCP, when to use UDP, and how do you handle services that use both of those protocols.